talk about Newton. Newton, everyone knows who is he. He's a scientist and he knows as his natural inventions. In this video, we talk about his early life, midlife, late life personality, enlightenment, and many more things. We will discuss. Sir Newton, he is born in 25 December 1642 and he died in 1726. He was an England polymath, active as a mathematician, physicist, astronomer, alchemist, and author who was subscribed in his time as a natural philosophy. He was a key figure in the scientific revolution and the Enlightenment that follows. His pioneering books, Principia, Natural Principle Mathematician, was published in 1687. Consolidate many previous results and established classical machines. Newton was also seminal contribution to optic and share credit with German mathematician. In the principle, Newton formulated the laws of motion and universe gravitation that formed that dominant scientific viewpoint for centuries until it was surprised by the theory of relativity. Newton used his mathematical description of gravity to drive Kepler's law of planetary motion, account for tides, the trajectories of comets, the precessions of the equinoxes, and the phenomena eradicating doubt about the solar system. He demonstrated that the motion of objects on earth and celestial bodies could be encountered for by the same principle. Newton interfered that earth is an obstacle spheroid was later confirmed by the geodetic measurement of Condamine and other convincing most European scientists to the superiority of Newton mechanism over earlier systems. Newton built the first practical reflecting telescope and developed a sophisticated theory of color based on the observation that a premise separate white light into the color of the visible spectrum. His work on light was collected in his highly influential book Optics, published in 1704. He also formulated an empirical law of cooling, made the first theoretical calculation of the speed of sound, and introduced the notion of the Newton fluid. In addition to his work on circular as a mathematician, Newton contributed to the study of power series, generalized the binomial theorem to non-integral exponents, developed a method for approximating the root of functions, and classical most of the cube plant curve. Newton was followed at Trinity College and the second professor of mathematician at the University of Cambridge. He was a devout but unorthodox Christian who privately rejected the doctrine of Trinity, of refused to take holy orders in the Church of England. Unlike most members of the Cambridge faculty of the day, beyond his work on the mathematical science, Newton decided much of his time to the study of alchemy and the biblical chronology, but most of his work in those areas remained unpublished until long after his death. Politically and personally tied to the Whig Party, Newton served two brief terms as a member of parliament for the University of Cambridge in 1689 and 1619 and 1701-1702. He was the king hurt by Queen Anne in 1705 and spent the last 3 decades of his life in London, serving as warden 1696 to 1699, and the Master 1699 to 1729 of the Royal Mint, as well as the President of Royal Society. Let's talk about the Newton early life. Newton was born according to the Julian calendar in used in England at that time on Christian Day 25 December 1642, NS 4 January 1643, at Woolsthorpe Manor in Woolsthorpe by Costhrowood, a helmet in the county of Lincolnshire. His father, also named Newton, had died 3 months before born. Newton was a small child. His mother, Hannah, reportedly said that he could have first inside a quart mug. When Newton was 3, his mother remarried and went to live with her new husband, the Reverend Barnabas Smith, leaving her son in the care of his maternal grandmother, Margery. Newton disliked his stepfather and maintained some enmity towards his mother for marrying him, as revealed by this entry is a list of sins committed up to the age of 19, threatening my father and mother Smith to burn them and the house over them. Newton's mother had 3 children, Mary, Benjamin, and Hannah, from the second marriage. The King's School. From the age about 12 until he was 17, Newton was educated at the King's School in the Grantham, which taught Latin and ancient Greek and probably imparted a significant foundation of mathematician. He was removed from school and returned to Woolsthorpe by Costhrowood by October 1659. His mother, widowed for the second time, attempted to make him a farmer, an occupation he hated. Henry Stock, master of the King's School, persuaded his mother to send him back to school, motivated partly by a desire for revenge against a schoolyard bully. He became the top-ranked student, disgusting himself mainly by building sandals and models of windmills. University of Cambridge. In June 1661, Newton was admitted to Trinity College of the University of Cambridge. His uncle, Reverend William Ascot, who had studies at Cambridge, recommended him to the university at Cambridge. Newton started as a subsizar, paying his way by performing valet duty until was awarded a scholarship in 1664, which covered his university cost for more years until the completion of his MA. At the time, Cambridge teaching were based on those of Aristotle, whom Newton read along with the more modern philosophers, including Descartes, and astronomers such as Galileo Galilei and Thomas Street. He set down in his notebook a series of questions about mechanical philosophy. As he found it in 1665, he discovered the generalized binomial theorem and began to develop mathematical theory that later became calculus. Soon after, the Newton obtained his BA degree of Cambridge in August 1665. The university temporarily closed as the precaution against the Great Plague. Although he had been undistinguished as a Cambridge student, Newton's private studies at his home in Woolsthorpe over the next 2 years saw the development of his theories on calculation, optics, and the law of gravitation. In April 1667, Newton returned to the University of Cambridge, and in October he was elected as the Fellow of Trinity. Fellows were required to take holy orders and be or- ordained as Angelica priest, although his was not enforced in the Restoration year, and an assertion of the conformity of the Church of England was sufficient. He made the commitment that I will either set theology as the object of my studies and will take holy orders when the time prescribed by these status 7 year arrived, or I will resign from the college. Up until the points he had not taught much about religion and had twice signed his agreement to the 39 article, the basic of Church of England doctrine. By 1675 the issues could not be avoided, and by then his conventional views stood in the way. His academic work impressed the Louisiana professor, who was anxious to develop his own religious and administrative potential. He became master of Trinity College 2 years later. In 1669, Newton succeeded him only 1 year after receiving his MBA. The term of the Louisiana professorship required that the holder not be active in the church, presumably to leave more time for science. Newton argued that this should ex- exempt, exempt him from the coordination requirement, and King Charles II, whose permission was needed, accepted this argument. Thus, a conflict between Newton and religious views and Anglican Orthodox was overturned. Newton was elected a Fellow of Royal Society. Let's talk about his midlife. Circulus. Newton's work has been said to distinctly advance every branch of mathematics then studies. His work on the subject usually referred to an fluctuations of calculus seen in manuscript on October 1666 is now published among Newton mathematical papers. His work De analyze per equations, Newton's terminology infinities, sent by the Iska Brown to John Collins in June 1669, was identified by the Brown in a letter sent to Collins that August as the work and the extraordinary genius and proficiency in these things. Newton later became involved in a dispute with Elizabeth over priority in the development of calculation. Most modern historians believe that Newton and Leibniz developed calculus independently, although with very different mathematical notation. However, it is established that Newton came to develop calculus much earlier than the Leibniz notation and the differential methods nowadays recognized as much more convenient. Rotations were adopted by continent European mathematicians and after 1820 or so also by British mathematicians. He worked extensively used circulus in geometric from based on the limiting value of the ratios of vanishingly small quantities. In the principle itself, Newton gave demonstration of this under the name of the method of first and last ratios, and explained why he put the exposition in this form, remarking also the hereby the same thinking is performed as by the method of individual. Because of this, the principle has been called a book dance with the theory and application of infinitesimal calculus. in the modern time and the Newton time, nearly all of this calculus, his use of method involving one or more orders of the indefinite smelly small in a present of de motu corporum is Guram of 1684 and his paper on motion during 2 decades preceding 1684. Newton had been reluctant to publish his calculus because of the feather, feared controversy and criticism. He was close to the Swiss mathematician Nicolas Fetieu. In 1691, Dulier started to write a new version of Newton's principle and corresponded with Elizabeth. In 1693, the relationship between Dulier and the Newton deteriorated and the book was never completed. Starting in 1699, other member on the Royal Society accused Leibniz of plagiarism. The dispute being broken out the full force in 1711 when the Royal Society proclaimed in the study that it was Newton who was the true discoverer and the label Elizabeth. It was the later found that Newton wrote the study concluding remark on the Leibniz do begun their bitter controversy with merit. The life of both Newton and Leibniz until the later death in 1760. Newton is generally credited with the generalized binomial theorem, valid for any expounded. He discovered Newton's identities, Newton methods, classified cubes, plant, curve, polynomial of degree 3 in 2 variable, made substantial contribution to the theory of finite differences, and was the first to use fractional indicate and the employ coordinate geometry to drive solution to Diophantine equation. He approximated partial sums of the harmonic series by logarithm up precursors to Euler's summation formulas, and was the first to use power series with confidence and the reward power series. Newton's work on infinite series was inspired by Simon's wit and academical. Let's talk about the opticistic. In 1666, Newton observed that the spectrum of colors existing a prism in the position of the minimum deviation in oblong, even when the light ray entering the prism in the circular, which is to say the prism reflected different colors by the different angle. This lead him to conclusion that color is a properly intrinsic to light, a point which had until then been a matter of debate. From 1670 to 1672, Newton lectured on optics. During in this period, he investigated the reflection of the light, demonstrating that the multicolored image produced by the prism, which he name of spectrum, could be the recomposed into white light by the lens and second prism. Modern scholarship has revealed that Newton analysis and rethink of the white light overs adapt corpuscle alchemy. He showed that the color light does not change its properties by separating out a color beam and the shining it on various objects, and the regardless of whether reflected, scatter or transmitted, the light remain the same color. Those he observed that color is the result of object interfacing that already colored light rather than the object generating the color themselves. This known as the Newton theory color. From this book, he concluded that The lens of any reflecting telescope would suffer from the depression of light into the color. As a proof of the concept, he conducted a telescope using the reflection mirror instead of the lens as the objective. By bypass the problem, building the designing the work non-fractional reflecting telescope today known as the Newton telescope involved solving the problem of suitable mirror. Reflecting telescope today known as the Newton telescope involved solving the problem of suitable mirror material and shaping the technique. Newton ground his own mirror out of the custom composition of highly reflective speculum metal using the Newton rings to judge the quality of the optics for his telescope. In late 1668 he was able to produce this first reflecting telescope. It was about the 8 inches long and it gave a clear and the larger image. In 1671, the Royal Society asked for the demonstration of the reflecting telescope. Their interest encouraged him to publish his note of color, which he late expanded into the work Optics. When the robot Hooke criticized some of the Newton ideas, Newton was so offended that he withdrew from public debates. Newton and Hooke had brief exchange in 1679 to 80 when Hooke, appointed to manage the Royal Society correspondence, opened up the correspondence indeed to elect contribution from Newton to Royal Society transaction, which had affected the stimulating Newton to work out of the proof that he elliptical from the planetary orbit would result from the centripetal force inversely proportional to the square of the radius vector, but two means remain generally on poor terms until Hooke that. Newton argued that light is composed of the practical or corpuscles which were reflected by the escalating into the denser medium. He verged on sound like wave. He explained the repeated pattern of reflection and transmission by thin film, but still retained his theory of fit that dispose corpuscles to be reflected. The transmitted, however, later physicists favored a purely wave-like explanation of light to account for the interface pattern and the general phenomena of diffractions. Today's quantum mechanic photon and the idea of wave practical duality bear only the minor resemblance of the Newton understand of light. In the hypothesis of light of 1675, Newton posted the existence of the either to transmit force between the particles. The contact with the Cambridge Palinoist philosopher Henry Maud received his interest in academic. He replaced the either with occult force based on hermetic ideas of attraction and repulsion between the practicals. John Maynard Keynes, who acquired many of Newton's writing of alchemy, stated that Newton was not the first of the age of reason. He was the last of the magicians. Newton's contribution to science cannot be isolated from his interest in alchemy. This was at the time when there was no clear distinctions between the alchemy and science, and had he not relied on the Aculus idea of action at the distraction across the vacuum, he might not have developed his theory of gravity. In 74, Newton published Optics, in which he expounded his theory of light. He considered light to be made up of extremely subtle corpuscles, that ordinary matter was made on grosser Puscale and the speculate that through a kind of alchemical transmutation are not gross bodies and light convertible into one another, and may not bodies receive much of their activity from their particles of light, which either their composite. Newton also constructed a primitive form of fraction elect, electrocism greater using a glass globe. In this book, Quick, Newton was the first to show a diagram using the prism as a beam expander and also used of multi-prism array. Some 278 years after Newton's discussion, multiple prism become central to the undeveloped of narrow line wide tube laser. Also the use of these prismatic beam expander lead to be multiple prism depression theory. Subsequent to Newton, much has been amended. Young and Fenrel describe Newton's practical theory of favor of hygienes. Wave theory of shown that color is the visible manifestation of the light wavelength. Since also slowly came to realize that the difference between the perception of the color and mathematicable optics. The German poets of scientists Goethe could not shake the Newton foundation, but one whole Goethe did find the Newton's armor. Newton had committed himself to the doctrine that reflection without color was impossible. He therefore taught that the object glasses of the telescope must forever remain imperfect, achromatism and reflection being incompletable. The interface was proved by Dolan to be wrong. Gravity. Let's talk about the gravity. Newton had been developed his theory of gravity as far back as 1665. In 1679, Newton returned to his work on celestial mechanical by considering gravitation and its effect on the orbits and planet with reference to the Kepler laws of planetary motion. The followed stimulation by the brief exchange of letter in 1679 to 80 with Hooke, who had been appointed secretary of the Royal Society and who opened a correspondence indeed to electric contribution from Newton to Royal Society transaction. Newton's revering interest in astronomical matters received further stimulus by the reappearance of the comets of the winter of 1680 to 1681, on which he corresponded with John Flamsteed. After the exchange with Hooke, Newton worked out of the proof that elliptical from the planetary orbit would result from the counterpedal force inversely proportional to the square and radius vector. Newton communication his result of Edmond Henley and the Royal Society in the Motive Corporation in Gurim. A tract written of about 9 sheets with the copied into the Royal Register book in December 1684. This tract contained the nuisance of Newton developed and explained to form the principle. The principle was published on 5 July 1687. With encouragement and financial help from Halley. In this work, Newton stated the three universal laws of motion. Together, these laws describe the relationship between any other, the force acting upon it, and the resulting motion, laying the foundation for classical mechanics. They contributed to many advances during the Industrial Revolution, which soon followed and were not improved upon the more than 200 years. Many of these advances continue to be the underpinning of non-relative technological into the modern world. He used to Latin word gravity, wait for three effects that would become known as gravity, and defined the law of universe gravitation. In the same work, Newton presented a calculus like method of geometrical analysis using the first and last ratios, gave the first analytical determination based on Pauli laws of the speed of sound in air, interface the oblates of Earth spheroidal figure accounted for the precession of the equinox as a result of the moon gravitational attraction of the Earth. Oblate initiated the gravitational study of the irregularities in the motion of the moon, provide the theory for the determining of the orbit of comets, and much more. Newton biographer David Brassel reported that the complexity of applying his theory of gravity to the motion of the moon was so great it affected Newton's health. He was deprived of his appetites and sleep during his work on the problem in 1692 to 1903, and told the astronomer John Mackin that he had never achieved but he when he was studying the subject. According to the Bristol Halley also told John Conduity that when pressed to complete his analysis, Newton always applied that it made his head itch and kept him awake so often that he would think or he no more. Newton made clear his heliocentric views of the solar system, developed in somewhat modern may become already in the mid 1680s. He recognized the deviation of the sun from the center of gravity of the solar system. For Newton, he was not precisely the center of the sun or any other body that could be considered at, at rest, but rather the common center gravity of the earth, the sun, and all the planet is to be esteemed the central of the world, and this center of the gravity either is at rest of the moves uniformly forward it a right line. Newton adopted at rest alternative in views common consent that the center wherever it was the rest. Newton made clear his heliocentric views. Newton postulate an invisible force able to act over and over vast distance, lead to him being criticized for introducing accurate genesis into science. Later, in the second edition in the Principia, Newton firmly rejected such criticism in a concluding journal, so, Scholium, Scholium, writing that it was enough that the phenomena implied a gravitational attraction as they did, but they did not so far indicate its causes, and it was both necessary and improper to frame hypotheses of things that were not implied by the phenomena. Here Newton used and became his famous expression hypothesis not fingo. With the principle, Newton became the internationally recognized. He required a circle of admirers, including the Swiss-born mathematician Nicola Fatio de Dulier. In 1710, Newton found 72 and 78 species of cube curve and categorized them into four types. In 1770, and probably the Newton helped James Stirling proved that every cube was one of these four types. Newton also claimed that the four type of could be obtained by plant rejection from one of them, and this was provided in 1731, 4 years after his death. Later life. Royal Mint. In the 1690s, Newton wrote a number of religious tracts deadline with the literal and symbolic interpretation of the Bible. A manuscript Newton sent to John Locke in which the disputed the fidelity of 1 John 5 is to 7 the John and its a fidelity to the original manuscript of the New Testament remained unpublished until 1785. Newton was also the member of the Parliament of England for Cambridge University in 1689 and 1701, but according to the same account, his only comments were to complain about the cold draught in the chamber and request that the window be closed. He was, however, noted by Cambridge Diocese Urbum the Priam. He have rebuked students who were frightening local by claiming that a house was haunted. Newton moved to London to take up the post of warden of the Royal Mint during the religion of King William 1696, a position that he had obtained through the patronage of Charles Montague, first Earl of then Exchequer. He took charge of England, great recognized Trode of the Toy of Lord Lucia, governor of the Tower, and the secured the job of deputy comptroller of the temporary Chester branch of Edmond Halley. Newton became the perhaps the best known master of mint. Upon the death of Thomas Naylor in 1699, a position Newton held for the last 30 years of his life. These appointments were intended of secure, but Newton took them seriously. He retired from his Cambridge duties in 1701 and exercised to authority to reform the currency and punish Kepler and counter factor. As warden and afterward as a master of the Royal Mint, Newton estimated that 20% of the coins taken in during the Grace recording of 1696 were counterfeit. Counterfeit was high treason, punishable by the felon being hanged, drawn, and quartered. Despite the convincing, even most flagrant criminal could be extremely difficult, but Newton proved equal to the task. Discussed as a habitude of the bar and trade, the gather much of the evidence himself for all the barrier placed to the prosecutions and separating the branches of government. England law still had ancient and formidable custom of authority. Newton had himself made a justice of the space in all the home counties. A draft letter regarding the matter is included in Newton's personal first edition of philosophy, natural principle mathematics, which he must have been amending at the time. Then he conducted more than 100 cross examination of witness, informer, and suspect between June 1698 and Christmas 1699. Newton successfully processed 28 coiner. Newton was made president of the Royal Society in 1703 and the associate of the French Academy of Science in the position at the Royal Society, Newton made an enemy of John Flamsteed and the Astronomer Royal by pre- prematurely publishing Fla- Fla- Flamsteed's historian, which Newton had used in his studies. Knighthood. Let's talk about his knighthood. In April 1705, Queen Anne, King King-hearted Newton during a royal visit to Trinity College, Cambridge. The kinghood is likely to have been motivated by political considerations connected with the parliamentary election in May 1705, rather than any recognition recognition and Newton's scientific recognition and the Newton scientific work or service as a master of mint. Newton was the second scientist to be the king-hearted after the Francis Bacon, a result of the report written by the Newton on 21 September 1770 to the Lords Commissioner of His Majesty Treasury. The relationship between gold coin and silver coins was changed by royal proclamations on 22 December 1770, forbidding the exchange of gold gains for more than 21 silver shillings. The inadvertently resulted in a silver shortage as the silver coins were used to pay for imported, while export were paid for in a gold, effectively moving Britain from the silver standard to the first gold standard. It is matter of debate as to whether he intended to do this or not. It has been argued that Newton conceived of his work at the mint of the continuations of his alchemist work. Newton was invested in the South Sea Company and lost some $20,000, that is $4.4 million in 2022, when its collapsed in around 1720. Towards the end of his life, Newton took up residence of Carberry Park and with his niece and her husband until his death. His half-niece Barton served as his hostage in a social affair at his house on Street in London. He was her very loving uncle, according to his letter to her when she was recovering from smallpox. Let's talk about the Newton death. Newton died in his sleep in London on 20 March 1727, 20 March 1726 and 31st March 1727. He was given a ceremonial funeral attended by the nobles, scientists and philosophers, and was buried in Westminster Abbey among king and queen. He was the first scientist to be buried in the abbey. Voltaire may have been present on his funeral. Bachelor, he had devastated much of his estate to relative during his late year and died in trust. His paper went to John Counted and Cathedral Barton. Shortage after his death, the plaster that mask was module of the Newton. It was used by the Flemish sculptor John Michel is making a sculpture of Newton. It is now held by the Royal Society, who created a 3D scan of in it 2012. Newton hair was posthumously examined and found to contain mercury, probably resulting from the alchemical pursuits. Mercury poisoning could explain Newton's eccentricity in later life. Let's talk about his personality. Here is a lots of about the Newton. Next video I'll talk about his personality. I'll make the two videos. This is the part 1 video about the Newton, and I will read further in the part 2.